Hello and welcome to Tribe Topper. I'm Sonal Gupta, and this channel is about increasing your understanding of physics. To clear your concepts, subscribe to our channel and click the bell icon for latest updated videos. Well, in this video session, you are going to learn about the Sankey diagrams. So, what is a Sankey diagram? As you can see here, that a sort of a flow chart, right? This particular diagram that you can see is called a Sankey diagram. So what is it? It's basically a visual representation of the flow of energy in a device or in an entire process. See, because different power stations, they will have different types of energy losses happening in the process. So their efficiencies are also different, and based on that we draw the Sankey diagrams. So the width of the arrow is important here because the width of the arrow corresponds to the percentage of that quantity. Like if you can see here that this diagram shows this is the entire width, right? That's for 100% energy that was produced from burning of coal. Now, out of that, during the generation only, the power loss that happened is 65%. So we have a wide arrow indicating a 65% energy loss. Then you have a 2% energy loss. So out of 100, 35 is left, which goes further. So only this much wide arrow is left out. Then you have 35 going 2% in transmission losses. So that's a thin line because 2% is a small percentage. So that has a thin arrow. Then another 2% lost in distribution, another thin arrow. Then another 1% loss in domestic wiring, another thin arrow. And then you have 28% is lost in the lamp's internal energy. So 28% is again a bigger amount, so that has a wider arrow, but the width of this arrow is less than the power loss because that was 65%. So 28% is this width of the arrow, and in the end, just that 1% is lost in the lampshade. Final useful energy is 1%, a thin arrow. So the entire width, which started from this 100%, is giving you just this one thin arrow as an output. Rest all are the power losses that happen. But the width of the each arrow corresponds to the percentage of that particular energy loss. So let's draw one Sankey diagram for a particular situation. So an electric kettle of rating 2 kilowatt is switched on for 90 seconds. During this time, 20 kilojoules of energy is lost to the surroundings from the kettle. So draw a Sankey diagram for this energy transfer. So out of the energy supplied in 90 seconds, so let's find out how much energy is supplied in 90 seconds. That's 2 kilowatt, which means 2 into 1000. So 2000 watt, and energy is power into time. So it is being kept on for 90 seconds. So using the formula of energy is power into time, we have 2000 into 90, which gives us 180 kilojoules of energy. Out of this 180 kilojoules of energy, 20 kilojoules of energy is lost to the surroundings. So 20,000 joules out of 180,000 joules gives you how much of the efficiency. So that is around 11% efficiency. So according to 11%, sorry, not efficiency, this is the 11% is the loss of the energy that happened. So 20,000 joules is lost out of 180,000, which is 11% lost. So what we will do is we'll take one big arrow, one wide arrow indicating that this was the energy coming up. But here we'll take a little wider arrow indicating a 11% energy loss. So you just draw an arrow here. This width represents 20 kilojoules of energy lost to the surroundings, and rest all is going out. So 180 kilojoules is out of 180 kilojoules, 160 kilojoules is going to heat up the water. So that's a simple Sankey diagram, but the width of the arrow would depend on the percentage of the energy. So that's all for this video session. In the next video session, we are going to talk about the energy produced in a nuclear power station. Thank you.